Hello, welcome back. In this video, I'm going to continue my discussion on multiple linear regression. This time, we are going to create a multiple linear regression model by using categorical independent variables, in addition to non-categorical independent variables. In this case, we do have a bank salaries data set where we do have several different employees, their education level, their grade information, their years of experience with the bank and in the industry, and their age, their gender, PC job. Not sure what this column represents, but it's categorical, and their salaries. So let's assume that we are interested in analyzing whether the bank discriminates against females in terms of salary. And these are the characteristics of each of these columns here. So as you can see, we do have categorical information, education is categorical, grade is categorical, years 1 and years 2, those are numeric, age is numeric, gender is categorical with 2 values, PC job is also categorical with 2 values, right? So salary in this case is going to be our dependent variable, and everything else is going to be our independent variables. Um, in Excel, if you would like to do regression in Excel, and if you would like to convert these categorical variables into dummy, if you would like to represent those categorical variables, you have to create a lot of dummy variables by hand. But in R, luckily, we don't have to do it by hand. It is automated in LM functions, linear model functions. And let's jump into it. So first, let me show you what bank salaries data set looks like. Um, you will see that I do have lots of salary information for my employees, and I do see their education levels. I wonder what this PC job means. It says, yes, if employee's current job is primarily computer related and no otherwise. Oh, okay. So that's also kind of important, I guess, in determining the salary information, but it's categorical information. So we are going to import this into our file. Again, I am working on multiple linear regression R, and I will clear my memory here, my plots. I would like to clear them up, and my console too. And what I'll do is I will import my bank salaries Excel file and name it as bank salaries. So Excel file, browsing, my bank salaries is here. Okay, I do that. I import. I do have it here. Okay. And let's call the structure str bank salaries. So this is a good first look into your columns. So you do see numerical columns here. Your age is numerical, your gender is character, PC job is character, basically male, female, no, or yes for your PC job. This representation is telling me that although my, for example, education grade is categorical, it's just showing me, those are just showing these two columns are just showing me that those are just numbers. I have to do, I have to find a way in order to convert them into categories. Otherwise, regression model is going to understand that those are just numbers. Those are not just numbers. Those are just categories um, um, that I have to be aware of. In addition, my gender and PC job, well, those are character values, right? So I have to tell R that those are actually, yes, character text based, but those are also categorical information. I have to do this processing in R before I run a multiple linear regression. And the way that I do it is by using as factor function. All I'm doing here is that I'm going to tell R that go ahead and modify these 4 columns in a way that those are represented as categories. As factor is going to do that. As factor is going to convert, for example, this bank salaries education data frame column into categories. Education column is now going to be, is now represented as numbers, but those numbers are going to be categorized as factors or different categories. So this num is going to go away, and factors is going to be replacing this numeric values in the education column. Same here for the grade, information, gender, and PC job. All right, so if you do this transformation, let's run 4 of them together. I'm going to hit comment and return. It did run it. Let's call now again one more time str bank salaries to see what happened. As you can see, education, it was numerical. Now it is a factor variable. It has 5 different levels, 1, 2, 3, 4, and 5, I believe. And grade has 6 different factors, right? It now understands that R understands that now education and grade is a factor variable, and gender and PC job is also a factor variable, right? So it understands that gender has female and male, and then PC job is no and yes. It goes ahead and categorizes, assigns numerical values for these text-based variables as well, right? Gender was only a female and male, and if it sees a female, it is assigning 2. If it is seeing a male, it is assigning 1. You don't see it here. If you try to open up the bank salaries, you still see no yes, male, female, but it is actually keeping in the memory as 2s and 1s, right? The reason is that linear regressions can't be done by using text values. So you have to find a way to assign numerical values so that you can run multiple linear regression. R does that automatically for us. Okay, let's call multiple linear regression model then, and we are going to call it LM5. All right, this is our 5th linear model today, or in this video series. A linear model function, we open it up, we use the tilde operator to define. To the left of tilde, we do have the dependent variable as the salary. And on the right, we do have everything else, right? We do have education, grade, years 1, years 2, age, gender, PC, job. And we use our data as bank salaries. Let's run this, and let's run the summary. And let me maximize this so that I could understand what this result is telling me. All right, so let's look at the ANOVA table. I do have my intercept. I do have education 2, 3, 4, 5, grade 2, 3, 4, 5, 6 column here. What is going on? I don't have multiple education categories. I did not have them when I entered them here. Well, it actually did it for me. Well, remember education column had 5 different factors. And as a result, you do see education 2, 3, 4, 5. What it does is actually creates 5 different education columns for me. And it represents each value of the education, each category of the education column as one independent variable. And it takes education one grade as the reference grade. So it basically tells me that if all these 0, then it is referring to the education 1 category. Okay, it's a little bit hard to understand at first, but multiple linear regression models with categorical variables work only if you have a reference category in the equation. So it did the same thing for grade, for example. Grade had, let's see how many categories grade has. Grade had 6, and it created here 5. You could see the only 2, 3, 4, 5, and 6. Grade 2, 3, 4, 5, 6 independent variables here, and grade 1 is taken as a reference grade. Okay. So if in the multiple linear equation you do put 0 for grade 2, 3, 4, 5, 6, you would be referring to the grade 1. Okay, years 1 and years 2 came in, and gender male is represented here. And if gender male is 0, then we are referring to gender female, and PC job yes is taken as the categorical variable that's coming out of PC jobs. So PC job no is taken as the reference column. So you do see that these are not statistically significant in explaining the salaries, the education categories and grade category. okay, grade 2 category, but other grade categories are statistically significant because the p-values are less than 0.05. Years 2 is not, and age is not, and gender male or female is statistically significant, and PC job yes is also statistically significant. Okay. Um, yeah, so these are the coefficients of these variables, and the way that you represent, for example, grade 2 is by just putting, if it is grade 2, you are just going to consider this coefficient in the equation and put grade 3, 4, 5, 6, 0, right? And it would make it grade 2. If it is grade 1, what you do is you are going to ignore these grade 2, 3, 4, 5, 6 coefficients. And if they are all 0, then you would be referring to grade 1. And same here for education 2, 3, 4, 5. And if your, for example, data set is for a female person and a bunch of other information into it, then you are not going to incorporate this in your equation, and you would be automatically referring to a female employee in your linear regression function. Okay, so what do we do with these p-values, with these variables with p-values larger than 0.05? This is the topic for next week, but a quick hint would be dropping them out. But we do drop them out one at a time because we would like to rerun the multiple linear regression model to see um, if it brings out all others, the rest of the variables as statistically significant. We look at the p-value with the highest. We look at the variable with the highest violating p-value. In this case, it will be age, for example. And I would be dropping this out and rerunning this regression line without age to see, to see the next version. And I keep going like this. But important information here is to drop these violating variables one at a time with the starting from the largest p-values. And until I reach a multiple linear regression model with all variables statistically significant, then I stop there. Okay. All right. Let's try to run another linear regression model by using only gender and years 1 data. In this case, if you pay attention, I am suspecting that there might be a relationship between gender and years 1 data that is also giving me more information. Okay, so and the way to represent the relationship or interaction between two different independent variables is to use the star function. I am literally telling my linear model that I would like to represent salary, my dependent variable, as a function of gender and years 1 column plus their interaction. Okay, let's go ahead and run this line and run the summary and try to look at the ANOVA table. You see that my salary information is now dependent on my gender male. It is statistically significant, my years 1 information, and this gender male and years 1 interaction. Okay, so you're actually the way that you can convert this into a linear, multiple linear regression function would be this. So you are actually telling that your salary is equal to, let's comment this out first, your intercept value, okay, your intercept value plus your gender male times gender male. Let's keep going. And years 1 times years 1 plus gender male years 1 interaction. So interaction column means actually multiplication here. And you could copy and paste the coefficient of this interaction like this. Okay, so let's assume that you have an employee who is male. Okay, so assume you have an employee who is male and 30 years old. So you could actually run this function to calculate it's your employee's salary, right? So this is your coefficient, right? So this is the coefficient for gender male. Since it is male, we replace it with 1, okay? And years 1, actually it is, well, not the age. So actually, let's assume that who is male and working for the company for 30 years. All right, that's what I believe years 1 meant. Okay. And again, years 1 is 30. Gender male is going to become 1. And years 1 is 30. So this would give me, if you execute this, 76,264 would be my estimate for this employee. And my multiplier square here is just 63%. It is telling me that this is not really that much quality work. It is only explaining 63% of the changes or the variations in the salary, and the remaining is coming from the rest. But yeah, this is how you would implement it this way. If your employee was female, how you would calculate it. So let's assume that you have an employee who is female and still 30 years old. Sorry, still working for the company for 30 years. And you would come over here, replace this gender male by 0 because our reference column, reference category for gender was female. And we had the coefficient for gender male. So we want to make sure that this disappears. And wherever you see gender male here as well, we replace it with 0, and we rerun this. You would see that same female employee would only be making $42,000, almost $43,000, 30K less than your male employee. Okay. This is how you could actually run multiple linear regression with categorical information. I will comment these out, but make sure that you try them with your own time. And let's try to actually see whether we can visualize these interactions on some visuals. For that, you have to install the interactions package. I already did that. That's why I commented it out. Make sure to uncomment this first run this line 63. Make sure that you run this to install interactions package. And after you do, make sure to uncomment it because you don't want to rerun this again. It will be a waste of time. Let's pause here, pause this video here after you run this install packages and make sure that it installs. After you come back, make sure to load this library interactions, and let's call the interact plot function. Interact plot function is going to help us visualize the changes of the gender on the dependent variable. So the way that you do it is you call your linear model, and then we are going to call LM6. LM6 is the model that we ran here, okay? And we only ran it by using gender and years 1 data. We are going to put the continuous variable in the pred category, right? Years 1 was continuous. And modx is going to have the categorical column. In this case, it was gender. And let's run this to see what it gives us. Well, it gives us a visual, and you could see that males, as years one, as the years working for the company goes up, females are making much less compared to males, right? You could see the pay differences over this visual here. All right, this will be the end of multiple linear regression discussions. Hopefully, we will continue multiple linear regression discussions on the next module.